In this video, we're going to derive two inverse trig functions. We're going to derive inverse sine, and we're also going to derive inverse secant. Now, you should have watched the video prior to this one that talks about how you can turn something like this into right triangles. So assuming that you've watched that, let's now jump into this derivative. We have to do a right triangle on this because we're going to use parts of this later on when we do our derivation. So for this, since there's a u there, we can write this as u over 1 to get two sides of our triangle. We're assuming that the u is positive, so it means that we can draw this in the first quadrant. We're going to use our definition for sine to label the two sides. Sine is opposite over hypotenuse. So I have a u and a 1 for this one. I need to use Pythagorean theorem to figure out the missing side. So I have a squared plus u squared equals 1 squared. 1 is your c value. It's opposite the right angle. When we solve for a squared, we get 1 minus u squared. Square root both sides means that we get the square root of 1 minus u squared. And again, you can't simplify that any further. So I get this right here. We're going to come back to this drawing. We want to have something labeled this way because we're going to use it later on. So now that we've done this preliminary work, let's now jump into the derivation. This right here, we want to write that a different way. So instead of having it solve for y, I'm actually going to write it a different way. So remember that when you take inverse trig functions, normally you start with the value and you get the angle. But if you have a regular sine, you can do sine of the angle and it'll give you the value. So I can write this as u equals sine of y. That's saying exactly the same thing as this one. I'm starting out this way because then what I'll do is take the derivative of both sides. So on the left-hand side, the derivative of u, I'm just going to put u primed. I don't know what u is, so I'm just going to leave it as u primed. Now on the right-hand side, this is going to be involving the chain rule because I got something inside that's not just a regular x on here, because we're actually taking the derivative of all these with respect to x technically. So when we do that, derivative of sine is cosine, so you do the outside function first, but then you have to multiply it by the derivative of the inside, and that's going to give you y primed. The y primed is important here in this problem because this is what you're trying to solve for. So now let's solve for it. If I solve for that, I get y primed equals u primed over cosine of y. Now here's where the right triangle is going to come into play. I want to replace cosine y with something from this triangle that involves u. Now I'm going to use the definition. What are we saying here? We're saying that the angle of this triangle is y. That's actually what this originally says here because y is an angle. So because of that, we're going to replace cosine y with an expression from the triangle. So cosine is adjacent over the hypotenuse. So adjacent square root of 1 minus u squared over 1 means that you're just going to get this. So I can replace the cosine y with this, and I get square root of 1 minus u squared, and that's it. That's going to be your derivative. We've solved for, originally started with y, now we got y prime. So this is basically, if you have something that's u, if you have x's, then you just have all x in there. Basically, if you have an x there, the derivative of x would be 1, so you'd have 1 over 1 minus x squared, but now this is generalized in case you have something else inside that's not x. So now that we've derived the derivative of inverse sine, let's now take a look at the derivative of inverse secant. Okay, we just looked at the derivation for the derivative of inverse sine, so now we're going to do that again for inverse secant. We're going to start out by doing the same thing as before. We're going to draw a right triangle that relates this information. I have a u over 1, I'll write that as. Secant is hypotenuse over the adjacent, so I'll put these into my triangle, u over 1. And then I need to solve for this missing side with Pythagorean theorem. A squared equals, or a squared plus 1 squared is going to equal u squared. Okay, so a squared plus b squared equals c squared. Your c again is opposite the right angle. We're going to solve for a, and if we do that, we get the square root of u squared minus 1. So we have this part here, subtract the 1, and we get that for our a, that's this side right here, square root of u squared minus 1. Now we're going to rewrite this as we did before in the previous example. We write this as u equals secant of y. We want to solve for u because then we're going to take the derivative of both sides with respect to x. The derivative of u is u primed. Derivative of secant is secant tangent. So we're going to do secant y tangent y, and then don't forget that we got to use chain rule here. We did the derivative of the outside function, secant tangent, but then you want to do the derivative of the inside, which gives you the y primed. Then we can solve for y primed. Y primed is equal to u primed on top over secant y tangent y. Now normally I would grab both these values like before and take them off of here, but this is going to be done a little bit differently. What we're going to use is we're going to use identity tangent squared y plus 1 equals secant squared. This is an identity from Trig, from pre-calculus. If I solve for tangent, what I'll get is tangent of y is equal to the square root of secant squared y minus 1. So instead of writing it in terms of tangent, I'm going to write it instead as this. Now, one thing to keep in mind there is when you take the square root, you really have plus or minus in this case. So you have to actually account for plus or minus on this one. Which means that when I put this in, I get plus or minus u primed over secant y times the square root of secant squared y minus 1. Okay. So that's where I get plus or minus from. I can put in my substitutions from my the triangle that I have here. Secant y is what we originally set up, so I could actually just take it off of here, or just recognize again that everywhere I see a secant y, I can replace it with a u. So therefore, this problem right here, and get some space here, your y primed can be written as u primed over u, and don't forget there's plus or minus here, u squared minus 1. Okay, so plus or minus u primed over this. So what are we going to do about the plus or minus? Okay, this is where you have to take a look at the graph. And if you look at the graph of inverse secant, it kind of looks something like this, where you have something like that and you have another one like this. Okay. Now if we take a look at the slopes of all these, because remember that your derivative is the same thing as a slope, tangent line here is both positive. So therefore I know that this is always going to be positive no matter what. So what we're going to do here is, because we're talking about the inverse secant and it relates to this one, what we're going to do is we're going to erase the plus or minus and we're going to put a absolute value around the u. The reason why is because that's going to take care of the plus or minus situation. The absolute value guarantees that what you put in there for u is always going to be something that's positive, and that's going to be reflected here on the graph itself. So this right here is going to be your derivative of inverse secant. You need to put the absolute values in there in this case. Okay, so here's the two that we derived. We derived the inverse sine and inverse secant, and here's all the other ones for you. So now you have all 6 of the inverse trig functions. And again, these are all in terms of u, but if you want to make them in terms of, if you have an x inside, then the top part just turns into a 1, because on top you'd have u primed, and that would still work even if you have a regular x on the inside. But all these are given to you as far as using a chain rule for each one of those.